Alrighty, so in this video we are going to talk about how we're going to determine our asymptotes. So if we have a rational function, one with a fraction, we're going to start by factoring both the numerator and the denominator. If possible, get rid of our common factors. Just cross them out. If there's a common factor, there's going to be a hole in the graph at the remaining function at any zeros of those factors. Okay, we'll show you that here, what that means in a minute. And then for our vertical asymptotes, that's what y equals. Or I'm sorry, what x equals. Our vertical asymptotes are what x equals. That's our denominator. Vertical asymptotes are determined by the denominator. So you set your simplified denominator equal to 0 and solve for x. I don't know why it doesn't say that, but solve for x. We're going to solve for x equals a. If a is a 0 of the denominator, then x equals a is a vertical asymptote. We're going to find our to determine our other asymptotes, our horizontal asymptotes. We're going to look at the degree of the numerator and the denominator. The largest exponent of the numerator and the denominator. If the numerator is a lesser degree than the denominator, there is a horizontal asymptote at y equals 0. If the numerator has a lesser degree than the denominator, so if I give you like 2 over x, then there's a horizontal asymptote at y equals 0. If maybe I'm going to give you x squared over x to the third, we have a horizontal asymptote at y equals 0. If the numerator and the denominators have the same degree, then there is a horizontal asymptote for the ratio of the leading coefficients. What that means, if I say f of x, let's say it's 6x squared over 2x squared. The leading coefficients have the same degree. That means we're going to have a horizontal asymptote at y equals 3. If the numerator is of degree exactly 1 more than the denominator, that's the important part. The numerator is of exactly 1 more degree than the denominator. We're going to have a slant asymptote, an oblique asymptote. So to define it, divide the numerator and the denominator by the denominator and disregard the remainder. Set the rest of our quotient equal to y to obtain our equation of our asymptote. And so we're going to see what that looks like here in a minute. So let's give the equations of any asymptotes or holes. Let's find our intercepts or any other key points necessary to sketch this graph. Alrighty, so when I am looking at this, the first thing I want to do is take the numerator and the denominator and I want to factor them. Well, on top, x plus 1 does not factor. And then we're going to factor the denominator. The method I like to use is I am going to ask myself what two numbers multiply to give me -6. And I got -6 by doing 2 times -3. And I need those same two numbers to add to +5. Well, what I'm thinking is we're going to do 6 and -1. 6 times -1, that's -6. 6 plus -1, that's +5. So then we're going to have x plus 6, x minus 1. Divide the values by the lead coefficient. So we're going to have x plus 3 and 2x minus 1. So x plus 3, 2x minus 1. Boom. Now let's find our asymptotes. Well, we are told there is a vertical asymptote. We are told there's a vertical asymptote every time the denominator x gives me a 0 on the bottom. So we are going to have vertical asymptotes at x plus 3 equals 0. So we're going to have a vertical asymptote at x equals negative 3, and we're going to have a vertical asymptote at x equals 1/2. That's from this one. Okay, our horizontal asymptotes. Well, that's step 3 in our procedure. So if you look back on the last page, you ask yourself, you check the degrees for the numerator and the denominator. And what I see is the numerator has a lesser degree than the denominator. This is portion A. The numerator has a lesser degree than the denominator. There is a horizontal asymptote at y equals 0. This is condition A for the horizontal asymptote. The numerator has a lesser degree than the denominator. And then we wanted to find our intercepts. So to find the intercepts, where do we cross the x and the y-axis? Let's find the x-axis. To find the x-intercepts, we are going to take our function and we are going to make, to find where we cross, y equals 0. And then we are going to solve this equation for x. I'm gonna solve the factored form because it's easier. Since we have a proportion, I'm going to cross multiply. Well, 0 times the entire bottom just gives me 0 equals x plus 1. So we have an x-intercept when x is negative 1. That's going to be the point negative 1, 0. Now let's find our y-intercepts. To find the y-intercepts, we are going to make all the x's equal 0 and solve for y. So y equals 1, because on top 0 plus 1 is 1. Then we're going to have 3 times negative 1. And that gives me negative 1/3. So we have a y-intercept at 0, negative 1/3. So when we graph this, we have a horizontal asymptote at y equals 0. We have a vertical asymptote at x equals negative 3. These are the lines that I'm not going to cross. And we have another vertical asymptote at 1/2. These are the lines that we are going to approach and never cross. All right, so now continuing with our graphing, you can notice we've basically cut our graph into 1, 2, 3 sections. So I'm going to address each section separately. So I'm going to look at my equation right here. I don't know why I can't remember the name equation. And I'm going to ask myself, what happens as x gets really, really, really negative? Bigger or more negative than negative 3. So when we're more negative than negative 3, what I'm going to have on top, we're going to have a negative divided by negative, because x is bigger than negative 3, so it's going to be a negative, times, let's see, this is going to be very negative, more negative, over a negative. So a negative over a negative times a negative, that's a negative. As x gets really negative, y is going to be a negative over a positive, which is a negative. So what that tells me, so I'm going to erase this out of the way so I can graph it. So as x gets really negative, y is also negative. I am on this side of the graph, and because my asymptotes are in the position they are, I know my graph will go like this. In this next group is where we have our x and our y-intercepts. our x-intercept was at -1, 0, so I know I'm going to cross the, I know what you're thinking, wait a minute, you said that that's a vertical asymptote. It is for when we just have a function, but you can see a rational part, but this is going to be a little different here. I'm going to show you how to deal with that. So we've got -1, 0, and then we've got 0, -1/3. So here are my intercepts on the graph. Okay? So what happens if we plug in a -2? -2 plus 1, so that's going to be -1 over 1 times -5, and a negative over a negative is a positive. So what's happening here is, so that's a -1 over a -5, which is a positive 1/5. So when x is -2, we're a positive y. So that means we're going to do like this. We're going to hit that point. We're going to come through our x-intercept, our y-intercept, and we're going to come down like this. Because we're only dealing with, we're not dealing with an x value without bound anymore. We're dealing with a specific x value between -3 and +1. And when we're dealing with these x values, we don't have any asymptotes. You can plug in any number between -3 and +1, and this won't give us any of our tricky restrictions because we aren't without bound. What about when we're dealing over here? If we have a super positive x value, so x is super positive, positive plus 1 is going to be positive over positive plus 3 is positive. 2 times a positive is a positive. A big positive minus 1 is still a positive. So this is letting me know my y values are all going to be positive on this side. So they are above, to the right and above these asymptotes. So not a great sketch of the graph, and if you have a graphing utility, it would do it much more justice than I would. All right, so when we come back, I am going to show you how we graph the other ones on the next video. So if you got any questions, please come to class with those questions and let me know. Have a good one, and I'll see you when I see you.